Hi everybody, able to hear me okay? Okay, great. All right, well, let's go ahead and get started. So we'll start with just a few logistical things about class. So first up, just wanted to let you know that I have posted grades for all of the quizzes and assignment submissions that I had as of, I think, yesterday or the day before. So you should have a grade on anything that you submitted there. I am currently going through your Checkpoint 2 submissions for your projects. You can expect feedback by Sunday at the latest. I'll try to get it to you sooner rather than later so that you know what exactly you need to do for the remainder of your project for the semester. For the vast majority of people, your projects are in a pretty good place right now, so it won't be a ton of work, and it shouldn't be something that will be overly demanding on you. But if I do have specific feedback, I will give it to you on this checkpoint assignment. And if you had questions, I'll answer those as well on that assignment. So I think pretty much everybody has turned this in. If you haven't, though, please do that as soon as possible. Okay. You have until tonight. Yeah, I mean, if you haven't submitted it, just, go ahead. I'm not going to count it late or anything. The main thing is that for you to get the feedback in time for your final project submission. Okay, so I've posted our last assignment for the semester as well. Assignment number 4, cinematic UIs. So let's take a look at it really briefly here. So this is kind of just kind of a fun assignment. It's not meant to really, be too taxing and more something enjoyable to do. So the idea is that there are a lot of TV shows and movies that have, user interfaces within them. And for the most part, these interfaces tend to be designed by people who are also building, the sets and the look of the show or the movie. And they're usually fictional interfaces that just kind of serve the purpose of whatever world is being captured. And sometimes they do some things that are pretty impossible in the world that we live in. So for this assignment, you'll just pick your favorite fictional user interface, or an interface from a movie or TV show. And it can be hardware or it can be software, whichever you like. So pick that, and then for the assignment, you'll submit a reference telling me what movie or TV show it is. If it's a TV show, include the episode, and also at what time it appears in the movie. Capture a screenshot of it to include with your submission, and then provide a description of the purpose of the interface, and then just a little brief commentary kind of about how it's used, or bring some HCI knowledge to the equation there. It doesn't have to be anything super detailed or profound, but just kind of pick a fictional interface that you see on TV. It can be a really good one or a really bad one, and capture that, get a reference to it, and write a little bit of commentary on it. And that will be our last assignment. And that's due on Monday, November 16th. And we'll look at the calendar in just a second, but that's kind of the last day that things will be due apart from the project. So also related, we have our last reflection, and I've posted it as well. And for this reflection, it's also kind of a fun, meant to be simpler assignment as we're here at the end of the semester. And it's basically just asking you to think about kind of how technology and user interfaces have evolved over the past 10 or 15 years. And then for the reflection, to answer these two questions, the first one being, what do you think the next 10 to 15 years will bring? And then the second one being, what challenges or areas of HCI do you think are going to be the most relevant or most interesting over the next 10 to 15 years? And obviously, we know that it's really hard to speculate correctly about anything like that. So it's not meant to be something where that you necessarily need to be correct about. But think about it a little bit, and then write up the reflection and read other people's, and then also maybe just save it and then take a look at it in 10 years and see how far off you are. That'll also be due Monday, November 16th, before midnight. For the final project details, I'm going to post a nice document that outlines everything, and I'll do that by tomorrow evening. But just to give you an overview of what you'll be submitting for the final portion of the project, it'll be a short presentation. The idea here being just create a presentation, and I'll give you the details of what needs to be in it. Create it, in PowerPoint or Google Slides or whatever, and then you'll just capture you presenting it. Just screen record that, and then you'll submit that as your presentation. And that way you can also include videos of your prototype, and you can edit it and show it nicely however you want. Like I said, I'll give you a lot more details in the document, but the general idea is you'll submit a brief presentation. The presentation will basically just show your project from the beginning to where it ended up. Question, let's see. Are we supposed to have our previous prototypes? If you don't have your previous prototypes, you can, in the presentation, just describe the changes. You've been editing and saving over it. Yeah, that's okay. You can look, if you submitted it to Canvas as a file, then you could probably download that and open it up if you wanted to get the older version. Another option is just to save a copy of your most recent one, and then just kind of make it look like it did earlier, right? Just degrade it a little bit to illustrate the progression. But you won't have to turn in the actual files of it. But for the presentation, you will want to show at least your sketches, a prototype, and then a revision or two of that prototype. That'll all be part of that presentation. And I should say that your evaluation of data will be part of the presentation too. So you'll turn in the presentation, you'll turn in the actual prototype files like we've been doing, your final ones, and any documentation that you might have, any instructions or anything to go with it. And then you'll also turn in your evaluation materials. So, the information about how many people evaluated it, what you asked them, and kind of what you gained from them evaluating your interface. So, and all of this will be detailed in this document, but just want you to have a general idea since we're getting pretty close. So all of this will be due Friday, November 20th, before midnight, and that's the day of our final. We won't have class or meet or anything for our final, but that'll be when the project is due, that final submission. So can we get a better look at this? in calendar view. Here we are today, and you've got the assignment, the last assignment, the last reflection, and I'll post the quiz next class, which will be a really short quiz. It'll be your last quiz. And I'll be posting the third exam, which will be a shorter exam than the first two. Hopefully everybody will appreciate that. And so I'll publish this exam. I'm definitely a week before on Monday. I'll try to get it out this weekend so that you have a little bit of extra time if you need it. But again, I'll make sure that it's not something that's going to take a ton of time. This is just my subjective opinion, but I think if you found exam 2 to be doable and you did well on it, you will do even better on exam 3. So exam 3 will not, it's probably, in my opinion, the easiest exam of all of them. Comment, forgot we had to report our progress. Yeah, you just go ahead and submit it as soon as you can. Just fill out that progress 2 report. And that's just so I can get you feedback before, so that you have at least a week or so to adapt your project if you need to. So I've got everything set, kind of all being due at once here. Like I said, all of these things except for the quiz and the exam have been posted, so you can submit them at any time. And for the exam, I really would like you to try to turn it in here. But I do understand that sometimes people, you have a lot of classes, you have a lot of finals or other projects. If you need an extension on this exam, let me know and we can do that. But it's better if you try to get it in at this point. The absolute deadline will be on this day because everything has to be graded in time for grades to be reported. Oh, hey, look, there's a numbering issue again. Huh. Should be 15. Well, okay. So with all of that said, are there questions? I know that's a lot. Okay. We have the survey paper. Yeah, so for grad students, the survey, the lit review assignment, you can make the 20th the deadline on that if you need to do that. Yeah. Okay. What about students graduating? How will grades be approached for them? If you are graduating, send me an email and remind me, and I will check and see what I need to do to make sure that everything for you can be put in on time. Change the due date of the exam to the 20th. Yeah. So, yeah, I'll note everybody in the chat if you're messaging me and wanting to extend that out to the 20th. That's fine. Yeah. So, Dawson just joined. Yeah, I can recap this at the end of class too. Okay. So. Oh, okay. Yeah, that's a good point. The topics, yeah, for the grad assignment. Okay, I don't think I posted those. I'm sorry. So for the graduate assignment, it is any topic that you want to choose, you can. But yeah, I told you I would post a few examples of projects, and I did not post those to Canvas. Let me just send myself a message about that. So I tend to, the only way I can force myself to remember to do something, usually I'm pretty good about it, but this has gotten lost twice, is I email myself about it because I try to keep the notification count down. Okay, so I've sent myself a message about that. I will do it after class. But yeah, if you read the assignment for the grad students, there's an example in there talking about what's too vague and what's probably specific enough, but I'll get you a few more of those. Okay, good deal. Okay, so last time we talked about HCI in the US presidential election, which I think is probably still going on, but we won't worry about that. Today we're going to talk about designing for non-traditional interfaces. And so I guess kind of the immediate question is, what is a non-traditional interface? And we've talked about quite a few of them over the semester. So pretty much anything that's not just a screen and a mouse, keyboard, or touch input can fall into this category of non-traditional. So one of the big ones that we'll spend some time on today are conversational interfaces. So speech-based, agents that you talk to, voice assistants. It can also be like chatbots or customer service chat kind of applications that you see frequently. Some other non-traditional interfaces we can think about things. You can think about kind of just our senses as humans. Haptics, gestures, sense of smell and taste. We talked about brain-computer interfaces a little bit. Augmented reality, virtual reality, social agents, so robots or avatars. We'll focus on these next week, so I won't talk about those in this lecture. But kind of this is the area we're in when we think about non-traditional interfaces. So to give you an outline of what we'll talk about today, we're going to look at voice interfaces and interactions specifically. Then we'll do a little bit of haptic interfaces, gesture-based interfaces, talk about some design principles for all of these things. And then we'll talk for a little bit about what I'm calling becoming part of the problem, but a little bit about things, and things being kind of this category that's emerged. You can think of Internet of Things, but small devices that are in your home, devices that you carry with you, that are usually connected to other devices that you use. And so we'll talk about designing those devices and kind of how you go about that, how you might get into doing things like that. But let's start with voice interfaces. So one of the kind of, I guess, the main question that you can ask when you start to think about developing an interface that's just based on speech. So think about just a conversational kind of interface. And you can think of something like a smart home speaker, so like an Amazon Alexa kind of thing, or Google's Google Home, is that what they call it now? And there's a lot of them. Even Apple has one that nobody uses. You can think about those things. And you can also think about these voice agents as they exist on your mobile devices. But kind of the question that you want to think about is what are users expecting when they're going to use an interface that's just voice, right? Let's for a moment say that there's no visual interface at all. It's just going to be speaking. What you find that makes this such a challenging space to design for is that humans use speech a lot. And we develop a lot of expectations about how it works. And it's really a lot different it doesn't lend itself well necessarily to rigid rules and to kind of what we can do in software necessarily. So one thing that, for example, that you find is people tend to use context automatically when they have spoken interactions. So that might just be, whatever environment you're in, you have a shared understanding with the person that you're talking to. And so you don't have to speak everything out explicitly. So that alone can be a challenge when you're developing an interface that's just going to be a voice, and especially if the only thing that your interface can do is listen to the user's voice and respond, right? It becomes a big technical challenge, because how do you know what the context is that you're in? You aren't a person in that environment. And so as you start to design an interface that's just based on voice, a big part of it is thinking about where you're going to be deployed at, what users will take for granted, how they would talk to another person in that environment, and start to design out for those scenarios. So it's a huge technical challenge, I should say, and it's all around a technical challenge, from everything from speech recognition, actually converting the voice into words, to natural language understanding once you have those words, to choosing a response that makes sense, to implementing like a short-term kind of memory and a long-term memory in a lot of cases, where you understand things about the user, you understand the relevant context that you're in. This can be very challenging from a technical perspective, and so we kind of have to design to accommodate some of those things that we're not necessarily able to do. So we have to make some assumptions there, and it comes from both sides. So the users, you can expect a user to adapt somewhat. You can kind of teach a user how to use a system, but you don't want that process of them learning it to be too unpleasant. So it's a lot like what we've learned about other interfaces and just interaction design in general. But you've really got to think about the specifics of speech and how that plays out. So just to talk about some general design guidelines, and we'll look at some specifics for some of the platforms that are most used today. But the first, kind of the biggest one, and this is, you can apply this to anything, but is setting expectations. So you need to tell the user what's possible. What can they say to this device? Because a lot of times, and again, if we're just considering a purely voice modality, no screens or anything like that, the user's just got this open prompt. And so you've got to somehow give them a hint or a constraint as to what's possible with the system. And so you also, though, you want to balance that with not being repetitive or too verbose and annoying, especially to people who have used the system before. So you're already kind of off to a rough trade-off spot. One thing that as we think about these voice interactions that take place, you always want to give users a easy way to exit or to ask for help, and you want to be pretty sensitive to this. So because you can, a voice agent can become quite annoying if it's it's not understanding what the user wants. So allowing the user to exit or get further help is kind of one of the most critical things to remember as you design something like this. Another area that's really quite interesting to think about is if you think about like navigating. So if we're doing a visual interface, right, you can rely on the fact that the options persist there in front of the user. So they don't necessarily have to put them into working memory and think about where they are in the menu. They can easily look and refresh their memory of that without much effort. When you're doing just voice, you've got to remember that when you say something to the user, if you're giving them options, they need to be able to remember them. So you're really, focused on limiting the working memory that you're using, and helping them know where they are in a process. So context reminders are fairly important in the way that you phrase things back to a user. Putting little indicators to help them know where they are in an interaction can go a long way. You always kind of want to demonstrate to the user how much information your system needs when they're asking something. So how much detail should they give? How vague can they be? So if you remember when we looked at like the Eliza chatbot script from way back, and it's just kind of a simple AI script, it didn't have any concept of like, I couldn't refer to the thing I just said right before. It doesn't support referencing that. So a lot of systems do support some context, but it's a matter of how much context. So we mentioned in terms of presenting options to the user, you really want to limit how many you present, because they do have to remember those. And then I've been talking about just using a voice interface, right? But obviously that can be quite difficult. So you want to use any visual feedback that you have available to you. So if you think about something as simple as like the early Amazon Alexa devices, just the blue LED ring around the top of the device, right? That would, animate and indicate that it was listening to you. That's, a world better than nothing at all, or just using the voice interface. A lot of devices, have screens and more complex displays as well, and so that can also be helpful. So I want to take a look at specifically some of the design guidelines for Amazon's Alexa. And if you're interested in these, I've got a link in the slides to them. So Amazon's got a pretty good website that goes through kind of their guidelines and the things that you should consider while you're designing for their devices. And of course their devices span quite a bit of territory, and they've been working on them for a while, but that's really nice, because when you read these guidelines, you do get a sense for things that they have learned over time implementing these voice assistants. So they divide it into 4 areas for Amazon's guidelines for Alexa, and those are adaptable, personal, available, and relatable. And I actually think these are pretty decent divisions of kind of the principles that you want to think about as you design for a voice interface. So just in case, if anybody's unfamiliar, you can develop for Amazon devices. You can develop skills for Alexa, and so anybody can do that. You can go to their developer website and learn more about that. And so this guidance is kind of what they provide to people who are looking to develop content for their platform. So we'll go through these, and I won't go into detail on all of them. I've got the link down here at the bottom for each of these. If you're interested, it's certainly nice to read. So the actual website does provide detailed examples for each of these. But I think these are pretty good things to think about if you're developing something like a voice interface that someone's going to use. So kind of this first principle of just being adaptable is that you don't want to trouble the user, or in their case the customer, when you don't have to. You want to do your best to be resilient for them. So a lot of these are things that people do with voice assistants that you should just be prepared to handle or to deal with early on. So the first thing is, people have a variety of ways of communicating their intentions. So a lot of work needs to be done in user studies and thinking about the specific domain in terms of different ways that people might ask for the same thing or say something. You can certainly prompt them and clue them into how you want them to say something, but they won't always do that. People do provide a lot more information sometimes than what you need, but you don't want to just reject that. So you need to be prepared for it. You also need to be able to know when you don't have enough information and be able to ask for that. One big thing is that you need to just support a basic repeat command, because sometimes people get distracted when they're talking to a person or talking to a voice assistant. So that's just essential that you be able to remind them where you're at in the interaction. We've got some about error handling here, and this is true across all interfaces we design for you. We want to handle errors gracefully. And so a point that is made specifically here for Alexa is that to think about the things that, like when Alexa can't understand what's going on, when the device understands but can't do the thing the user's asking for, and also if a response isn't generated when you're expecting one, you want to re-prompt for that, because you don't necessarily know where the breakdown was in this. So that's kind of a quick summary of this category that Amazon calls being adaptable. The next category that they have is called being personal, and this is an interesting one in terms of user experience. And making a product that is helpful to people that they like to use, and that can be competitive against other products. This starts to talk about learning and understanding the user that you're interacting with over time. So things like recognizing people who have used the device before, capturing information about their behavior without explicitly having to ask them verbally. Kind of the idea being to reduce the amount of verbal back and forth. You want to be adaptive based on this information that you know about the user. And I should say that what's kind of interesting in the case of a platform like Alexa is that Amazon's trying to guard their customers' privacy while also allowing third-party developers to make skills that use that data that's protected. So that's kind of a difficult design constraint already. And so it's interesting. If you're interested in that kind of thing, I would encourage you to read more of these design guidelines, because they carefully balance that, and that makes design a little bit harder for the third party, for sure. But it's more important to protect the user's privacy. In general, avoiding a lot of laborious data entry over a verbal system, over a voice interface is important. And then some Amazon-specific notes. So they do give you a tip if you have access to like a customer's location. Use that as context, but realize that you may not always have that permission. And another big thing that's kind of interesting is to keep your interaction flow going even once the user exits your app or your skill, in Amazon's case, to keep a nice flow going there. So the third category that Amazon gives guidance on is what they consider being available. And so a lot of this has to do with timing within a verbal interaction. And they do, in the detailed guidance, provide some data just about how people time conversations generally. So how long should you wait for a response from a user? These are all things that have been well characterized. Also, in terms of you want to avoid anything that's ambiguous with the user, And when you start to give like a list of items back, that's something that can quickly become unpleasant to use. And the pacing, the verbal delivery becomes important as well. As well as things like prompting the user to continue down a list. So you don't want to just plunge into it necessarily. You want to have reasonable limits. You really want to think about this interaction ahead of time. And you don't want a lot of unnecessary back and forth. So that kind of sums up most of the characteristics that they consider under availability. And the fourth area that Amazon emphasizes is being relatable. And this is a lot about how you author the content, the things that your skill, in this case, is going to say. So the actual utterances, what's the style of speaking. So one big thing is that you do want to speak to the user in a way that's friendly, that's conversational. They recommend, obviously being brief, as brief as you can be during conversation. One important thing, just as an aside, and the Amazon notes this as well, is speech synthesizers. So the text-to-speech systems often will pronounce things in a way you did not expect. So it's worth limiting the things you say just because of that. Even as good as they are today, we still have some issues with that. So I know when we do studies where we're going to have a robot speaking certain things, we always try to pre-render as much as we can, because in a lot of cases the speech engine may say something, may pronounce a word differently based on the context it's in, and it's not quite correct or typical. And so you want to correct that a little bit. You can't do that when it's a purely interactive system and you're not there to intervene. So, being cautious is important. They also recommend this one breath test, and that's kind of the idea of you should be able to get out the utterance without needing to inhale and take a breath again. It's kind of a quick rule you can apply to the things you're going to have the system say. Variation is really important in these systems. So users don't like things that are super repetitive when it's conversational. It's a little bit different in the visual interface, kind of like that consistency, but it's different for voice. So you want to have a variety of ways of saying the same thing, especially if you need to repeat things. You want to, again, these conversation markers, timeline markers, pointers, transitions, that's all about keeping context during the verbal interaction, and that's all really important for voice assistants. So Amazon also has a nice little set of pages helping you design a skill for Alexa. So these are the 3 steps that they kind of break it out into. Deciding what you want it to do, writing a script, and then kind of doing this storyboard process. And so they've got some great examples of that that I would encourage you to look at if you're interested in that. I thought I'd compare just briefly. I took a look at some of the Siri guidelines from Apple and some of the things that they talk about in designing for Siri. Now I should note that Siri's Apple has broadened Siri's applications beyond just a voice assistant. So some of these guidelines speak to that. But in general, they have kind of this high-level 3-phase process that they think of interactions with Siri having. And the steps they call them resolve, confirm, and handle. And a lot of this has to do with the information flow through, kind of Apple's SDKs and the third-party app and managing all of those interactions. But they kind of spell out what you do in each of these phases. So, initially you get some input from the user. The resolve phase is where you would ask for any clarification or anything that you don't have that you do need. Confirmation phase is for anything that's has an impact that needs a confirmation, whether that's sending a message or buying something. You want to get the user to confirm that. And then the final phase they have is the handle phase, which is where you provide information about what your app did. And so you see some information in visual and textual information because Apple does use Siri visually on their mobile devices when that's possible, but not always. And so what's important, and what I've noticed in Apple's guidelines specifically, is they ask developers to provide enough guidance so that the Siri actions and interfacing can work with or without a visual display. So if you're just talking through your headphones, for example, you won't have a visual display. But if the user does have a visual display, then you do need to have content for that. So Apple spends some time discussing guidance related to that. Again, we see some of the same things that Amazon discussed, and within Apple's guidance, things as simple as being prepared for people to not use an exact name or phrase, use alternatives. And so we see a lot of the same stuff here. I won't go through all of this in detail. If you're interested, you can check out Apple's design guidelines for Siri. Here are some examples, though, of kind of some of the guidance, some of the standards that Apple sets up for its ecosystem. So these are what Apple calls custom intent categories, and the verbs that are associated with them. So these are the categories. So like if you're downloading something, the default verb is in fact download, but you could also use get. So it's just a way to standardize across the platform. It's important to know that if you're building for a specific platform. Again, here's some more guidance that we see having a lot of overlap with kind of the general guidance and Amazon's guidance as well. Apple is very particular about how Siri itself is regarded, and in particular not attributing a gender to Siri itself, because, as you know, a user can choose the voice that Siri uses, and so the user may perceive that as one gender or another. So the guidance is to not have it use any kind of personal pronouns for itself or for others, for that matter. So that's interesting. There's a lot to think about there. So let's briefly talk about kind of just change gears and talk about haptic interfaces, which are kind of another non-traditional interface that's pretty prevalent. So kind of the haptic interfaces we all know are things like our phones, our watches, game controllers, and that's generally a tactile vibration haptic interface that we use there. When we think about it more broadly, there are two kind of categories that we can think about. We can think about cutaneous versus kinesthetic haptics, with cutaneous being things usually felt through the skin, and kinesthetic being more through muscles and tendons. When we think about hardware that's used in haptics, we have both actuators and sensors. So actuators, something that takes physical action in the world, whether that's a motor or a speaker or something that causes a vibration somehow. And sensors being things that monitor what's going on in the world, maybe monitoring what the actuator's doing, maybe monitoring what the user's doing and how they're responding. And we need to think about that haptics exist kind of across a wide variety of sizes, and they have varying portability. So something small, like a smartwatch or a phone, is very different from something large, like an exoskeleton, right? They have different sets of requirements and design features to think about. In general, when we think about haptic interactions, we want to think a lot about human perception and the things that we know about human perception. So things like how humans perceive, different thresholds of detecting a stimulus. Some of those things we talked about very early on with, sensation and perception. And we need to think about, how fast people detect a change, And in a lot of cases, we want to think about safety, depending on the strength of our haptic device. We want to remember that humans can be fatigued, injured, and things like that when they start to physically interact with these devices. So you always want to consider that. I've included just a figure here, and this is from a book that talks about. It's a little bit of an older book. It's called HCI, the GUI and Beyond. So that's what it looks like there. That talks about quite a few. You can see haptic, speech, smell, and a couple of other interface types. So that's where I've pulled this figure from. It's a decent a read, and it really characterizes a lot of things. And even though it's I think it's like a 2008 book, it's still a very good reference. So these are some haptic interfaces. In this case, this is kind of one of the most classics that you see. This is a force feedback like pin device that can allow you to kind of draw in 3D space and feel objects. It pushes back on you as you use it in space. And these are all different devices that give the user feedback of different kinds. Force feedback, so pushing with an actuator. Kind of an example of something else that is more of a, not so much a kinesthetic haptic, but is more of a kind of a tactile, cutaneous haptic. Is something like this. This is a navigational aid for people with impaired vision, and so this actually goes in the user's mouth and can haptically stimulate them to provide them directional input. So it can sense objects in space and convey that through haptic vibrations through the device to the user. And there are certainly a lot of examples of things like this. So you can, if you start to look at research in haptics, you'll definitely see a lot of applications for impaired vision. So some things to think about when designing for haptic interfaces. We mentioned that the kind of the limits and the characterization of the human is very critical. So things like thresholds, durations, sensitivities. Of course, the two types of haptic feedback that we've discussed. So if you think about something like giving a notification, like we might get from our phone or watch, versus helping someone explore a 3D space, right? In one of those, like the exploration task, you might have a user, they might have their hands in some kind of apparatus, and they're using it to feel through something, and you're using motors to push them at a big scale, right? So they push on their muscles, and they're getting feedback that way. Whereas if you're just giving them a notification, then you might just be doing kind of that just cutaneous, just the little vibration on their skin. And so those are two different spaces. Both of them have to think about things like how frequently and how big of a force you should use. They both have to consider the environment they're being used in. So even with something like just a notification on a watch or a phone, if a user is in an environment where there's more kind of background noise or background vibration, you may need a more prominent or longer notification, a haptic notification for that environment. Whereas if you're doing something like you're designing like a trackpad for a laptop, you probably want to think about the fact that someone might be using that laptop in an environment like a library or something where they want it to be quiet, and you've got to deliver the haptic feedback in a way that's not disruptive there. So that the context can matter quite a bit in this design, and also just how it's being used, right? So designing a game controller is very different from just like a phone or a watch that's notifying you of an alert. You do want to think about how the system is situated. We don't think about this too much now. We tend to think about mostly portable things. But when you're designing the sensory abilities of a system, if the system is going to be portable, it's a little bit more difficult in terms of the feedback you get usually. In some of these bigger, more controlled systems, you can do better optical tracking and things because you have certain guarantees. And in general, for haptics, like everything, user evaluations are really important. So iterating, trying things, and seeing what works and doesn't work for what you're designing for. I want to touch on, just briefly, gestures, which kind of go hand in hand with haptics. If you think about kind of the haptics being the system actuating on the user, gestures are kind of the user conveying something through their own actuation, and the system interpreting that. So this is nonverbal behavior. We can kind of categorize it into things that are mechanical or tactile. So like a mechanical or tactile thing, something like a stylus that a user physically moves around, and these gesture mechanisms can also generate haptic feedback, right? But also things like Nintendo Wii controller, even things just as simple as a multi-touch screen, right? Or a button, right, that you're pressing. They're physical, tactile things that the user interacts with, that come in contact with them. On the other hand, we have sensors that might use vision approaches, right, to see kind of what a user's doing. So things like tracking a user's body pose, or looking specifically at the gesture they're making, where they're pointing, right? Could be something looking at like their face, so just as simple as what's the orientation of their face relative to some target, or even as specific as where their eye is looking. We can also consider things like emotional displays, so when humans use facial expressions or gestures to communicate some emotional state or affective state, we can think of that as being a gesture. We'll use the same approach there. In terms of hardware for analyzing this kind of thing, today a lot of just plain visual spectrum cameras are useful for this, but also sensors that use different methods of 3D imaging, whether that's stereo vision or projected IR light or time of flight, sensors to get a 3D view of the environment. Those are all approaches to understanding gestures from a vision perspective without physical interaction and contact with the user. So just some general guidelines for gestures, and of course gestures are kind of their own involved area, but I think the most important thing to remember, if you remember anything about a gesture, is that the goal of a gesture is to make something more efficient or intuitive, not just to be a gesture for the sake of being one. You certainly don't want gestures that are more stressful or fatiguing than other means of doing the same thing with an interface. So you want them to be easy to perform, so ergonomic. They need to be intuitive, and you really want to think about people's mental mapping. A lot of times this depends on what domain you're in, right? So there can be general gestures. So if you think about something like, a lot of us are familiar with kind of the idea of like on a touch screen swiping something away, like just throwing it out of our view, or swiping through items and then selecting them by tapping, right? Those are kind of broad standards that we've developed that make sense to a lot of users. But when we think about specific applications, we can certainly develop custom vocabularies of gestures for those applications. And those are usually domain specific. So it could be something like a gesture for play or pause, maybe. It could be, if you're doing something like directing a robot, gestures for telling it to move in a certain direction or to slow down or to stop, right? And you can think about adapting gestures that people use in other modes of transportation, right? So when people, like a human guides someone who's driving a vehicle or piloting something, they typically will use hand motions that kind of indicate, go this way or stop, right? Or come back a little bit. So those are kind of embedded already in things we do. So again, that's all in that need finding process that we've looked at so much this semester. One thing that you've got to think about with gestures that's kind of interesting from a technical perspective is that you need to be able to distinguish reliably between gestures, so you don't want them to be too ambiguous, and this can depend on the underlying technology that you're using as well. So how well can you differentiate between the gestures that you've developed? One thing that I do want to mention that's I've experienced, and I haven't done a lot of work with gestures, but I've done a little. And specifically, I've done some work with tracking people's faces and head movements and mapping those into a remote space for a robot to allow people to kind of naturally look around a remote scene. And one thing that you've got to remember is that people might be using, like in this example, the interface to look remotely, but then someone says something to them and they glance off to the side, right? You need to design for that, to realize that they're no longer giving you input, right? So your robot shouldn't just fling its head off to the side as well. So there's this idea of kind of a context awareness, or in this case, a gesture zone is language you can use to describe that. So kind of even informing the user that, hey, when you make a hand gesture in this area, right, we're going to try to interpret that. Whereas, if you're over here, then you're fine to do whatever. It's not going to try to interpret it. And of course, what's important there is also feedback, is letting the user know what you're perceiving, what the system's perceiving from them, because that helps shape their expectations as they continue. And also I should mention, on another technical note, when you think about things like gestures, there's a great opportunity to tailor to and adapt to specific users if they're going to be using the system repetitively, to somewhat learn more about how they convey a certain gesture, and to allow the system to perform better for them. And of course, that's a careful balance between training the system to perform well for any arbitrary new user and to perform well for a specific user. It's something we see in all kinds of systems that use machine learning, that level of personalization can be helpful, and it's definitely something to think about in terms of developing gestures. So that's kind of a quick overview of just things to think about in designing gesture-based interfaces. Again, the most common ones that we have today are just multi-touch capacitive screens. And we certainly have seen gestures develop in that space just in the time that it's been available kind of in the mainstream. There have been gestures that people have attempted to make popular or useful that never really got widespread adoption, and there are some that are just incredibly direct and intuitive. Things like pinching to zoom, right? Just that direct manipulation that are universal. So definitely think about the platform you're on and kind of the domain that you're in. You're thinking about gestures. So I want to shift gears a little bit with the time that we have left today, and I kind of want to set us up for next week, where we'll talk about robots and augmented reality and virtual reality, and really just an overall very fun topic to look at. But I kind of want to motivate this idea a little bit of what I called things earlier, making things. And I've just pulled a few, just took some snapshots of some papers that I had saved, as I find interesting papers that I save. They kind of fit this idea of making things and looking at non-traditional interface design in its purest form, in my opinion. So this is a paper that's talking about actuation and sensing with this kind of deformable, shape-changing object that they've created. Here's another one that's talking about using these fabric kind of textile, in this case they're buttons with electronics inside of them, sensors. And obviously all these papers go into a great deal of detail. So using electronics and computation, embedding that in wearable things, in textiles. Here's another one. So this is talking about developing different types of multi-touch using different capacitive inputs. So in this case, these are little foil pads. In this case, this is conductive ink, I believe. Let's see, does it say that? That says using a lily pad. Okay. So I think they may have flipped their labels. This is a lily pad. So this is conductive thread here to detect touches. And this is a grid that gives you a higher resolution of what the user's touching. Also, you can see this being used on like a box object. There are a ton of examples of capacitive sensing specifically, and a lot of great papers on this. And you can see, like here, this is connected to a microcontroller to read these inputs and process them. And capacitive sensing, I should say, is something we see like really frequently used in children's toys to sense like touch and things like that. So that's like what you see, these foil pads on this object, this rabbit. That's commonly what you'll find inside of toys that interact with touch. They'll have foil pads under them, fur, or whatever their outside covering is. So thinking about things, I kind of want to argue to you that it's important that you think about them, whether you're a software person or not a software person, or kind of no matter your level of involvement or interest in creating physical things. I think it's important to learn a little bit of the basics of what's available today and how that's changing rapidly. So there's a big shift between now and I would say 10 years ago in terms of how easy it is to create a thing, an electronic physical thing that's connected typically to a network that serves some purpose, whether it's an input or an output, that makes life more interesting or easier for people. So mainstream examples that are really hardened are things like smart home devices, smart plugs, smart light bulbs, smart thermostats. Okay, those are things that are truly useful and are products that people are selling with guarantees and warranties and things. But I'm thinking about things that are before that, that are things that are prototypes that will become products later. So we've got these factors conspiring together over the past 10 years. This availability of off-the-shelf components, electronic components, software components, low-cost components, decreasing cost of the equipment needed to fabricate things, a lot of off-the-shelf platforms that do things, and a lot of resources to learn about these things, no matter what your formal background is. So I think this is pretty important to HCI and interaction design. And so I would also argue that things can be fun. So here are a few videos that I pulled just randomly, kind of from my own camera roll of just things. First, over here on the left, this is a Furby on top of a Sphero robot, because maybe a Furby needs to have mobility, right? So just pushing things together, hacking in Bluetooth, 3D printing some things. This middle thing is another use of the Sphero, is a 3D enclosure that mounted a 360 camera to that you can drive around and capture 360 video. This is going down a table in one of our labs. And then you can use software later to pan around and set up your shot there. Yes. Does the Furby need mobility? The Furby is more terrifying when it doesn't have its fur on there, which is pretty good. And then on the right there is just just showing a design process and how quickly you can make something. Yes, Furby mobility is nightmarish. I'll give you that. So here's another quick example. This is something we did in our lab one year for Halloween. We threw this together in an afternoon. So we made we connected these 3D printed little ghosts here to some RGB LEDs, built a little web interface and a live stream camera, and set it up so that people could stand down in the parking lot and look up in the window and fight each other and control the colors of the Halloween artifacts, right? So that's kind of combining these things just for no reason other than the joy of it. But these concepts kind of used to make these fun things are important in creating real products and in terms of just prototyping things. So we'll talk about this more next week on Tuesday when we talk about robots, and we'll do some practical examples of this. But I just kind of want to set the stage. We've kind of got these two areas of basic electronics, so sensors and actuators. Microcontrollers and single board computers are a huge area that has enabled a lot of things to happen. So being able to easily, change the color of an LED, or sense the temperature in something, or know if someone's turning something upside down, and to easily connect to Wi-Fi and transmit that, and interact with other sensors and actuators. These are all things that fall in this scope. And then also kind of fabrication skills. So whether that's using something as simple as scissors and foam board, or using something like some tools in a shop, or it's a drill press or a lathe, or doing things like just designing things in 3D software, which has become much more accessible and to a lot of people, and using something like a 3D printer, which the price of has come way down, is accessible to a lot of people, to create some novel part. And I should say that there are so many services available that can do these things for you without you even having to have these technical skills. But all of this, and this is just an example of 3D part making. Here's some videos just showing a time lapse of something being printed here on the left, and then something when the printer fails on the right, because 3D printers are still hit or miss. But the idea being that these are perhaps valuable skills to know about, and that the barrier to entry is not that high. And so I've shown you some of these photos of the prototypes that we make using 3D printing and this quick fabrication process. Really useful for people making robots. And there's like basic off-the-shelf electronic components used to make a robot. Things that are easy to learn how to use without a great deal of technical knowledge. I don't have to be an expert electrical engineer or an expert programmer, but knowing these things and knowing what's available and learning to use them at a basic level and connect them is really helpful if you're interested in going further into the world of interaction design and human-computer interaction, whatever your role might be in that. These are things that are going to be kind of valuable to know today. So I've included some resources links here in case you are interested. These are specifically electronics, and they do have a lot of basic 3D part printing and stuff. These Learn links are really good. We'll talk about this more on Tuesday, but I wanted to provide them here for anybody who's interested in this kind of thing. I think it's a pretty important and relevant area. So I want to sum up just talking about our action items for the rest of the semester, really. So you've got the reflection posted to Canvas. You've got the homework posted to Canvas already. These, except the project, are all due on the 16th. If you need an extension on the exam, we can push that off to the 20th too. Your final feedback will be coming by Sunday on your project, along with the specifications for the final presentation and the final deliverables, which is the recorded presentation and your prototypes. That'll be posted on Canvas as well. But this is kind of the rest of the semester in terms of deliverables that we have as a class. So that's everything that I want to touch on today. We will meet on Tuesday, and you don't want to miss Tuesday because we will play with a lot of robots and talk about augmented reality and virtual reality. So I'll hang out here for a few seconds, but otherwise, everybody have a great weekend, and if you need anything, just send me an email and I will get back to you as soon as I can.